Hey guys, welcome back to part 6 of coding asteroids in TypeScript. Today we're gonna do some refactoring and organize our code so it's easier to move forward with it. We'll also do some shooting to have some bullets flying around the screen. Alright, so let's jump in. So I'm gonna go back to my code editor, go to source, main.ts file. So currently we have a bunch of things going on here. We have the input player, a dummy asteroid, and the update and draw functions. So I'm gonna start picking out this stuff and putting it into its own class and move them off to different files. So let's start with this loop. I'm gonna just take it as is, create a new file called ticker, and then create a new class called ticker. Paste all of that here. Let's take a look. I'm gonna have a constructor. So constructor will take the frame rate, so that will be fixed. Now we can say delta time, so that will be our fixed delta time, and we'll move all of this stuff as properties. Okay, move lag, private lag equals 0. Delete the function keyword because don't need that anymore. I'm gonna make this private as well. Alright, so what do we need here? You can say this dot last time, this dot lag, this dot last time. So clear screen, we're not gonna have that here. We're gonna offboard that to a parameter. So we will take two functions here. We will register them as hooks, so we can say on fixed update, and we can have a callback here. That'll be a function that takes delta time and now. So this has the same signature as our update function from before. That's kind of long, so and we're gonna need that for the draw or the regular update. So I'm gonna create a new type from it and call it update callback. So I'll use update callback here, and then I'll create a regular update. So we'll use the on update as a render. So every time this ticker wants to render, we will call on update. So we will have that function here as well. Let's go back to the loop. We will fix all these. So now it won't be fixed delta time, it will be this dot fixed delta time to this dot lag. So draw, we will update it by this dot on update delta time, and now, and in this update, this was our fixed update, so we will say this dot on fixed update. Right, so on fixed update is, oh wait, yeah, we're gonna register these as properties. So we will say fixed update listener is update callback, right? And then we will have an update listener, and when we want to invoke these, we will just say this dot update listener, and we use the question mark operator to make sure it's not null. and we invoke it with, wait, we don't invoke it here, we just set it to callback, and we do the same thing for fixed update. Okay, and then we will call those listeners instead. So this will be this dot fixed update listener. Use the question mark operator to make sure it's not null. What's wrong here? Oh wait, I need the dot, do I? Like that? Yeah, okay. I'll do the same thing here, but with the update listener. So this drives rendering, or we can just call it on render if it reads a bit confusing. So we can just say render listener. So we can say on render listener, removes this render listener, and this dot loop, we invoke it like that. Now everything should be the same as before, and we will expose some function to start this ticker. So that's where we will invoke this dot loop. No, we will do request animation frame this dot loop. Wait, we don't need to do that. We can just say this dot loop and call performance passing performance dot now, and everything should stay as is. Okay, we can also define an end here. It's good to clean up it's good to clean up the resources. So request animation frame actually returns a handle, so we can store that in a property in our class. So private handle is 0, and then I want to get the handle on the start function. So let's do this. So let's do request animation frame this dot loop, and we will actually set the last time to performance dot now here as well, because that's when we actually start the ticker, not on that's we need to pass in, because the first time is gonna invoke, we need the last time to be actually the current time, not 0. That's what we had earlier, right? Because if you go back to main.ts, we were doing this. Okay, so I will say this dot handle equals request animation frame, and in end I will say cancel animation frame this dot handle. Okay, all right, we can start using this sticker class now. And yeah, okay, so yeah, actually I'm gonna take all of this stuff out and put it in the game class first. So let's create a game.ts. So we will store our game state in here. So things like player ship, bullets, asteroids, other business logic, behaviors. We can store those here, and we will have an update callback So this will be from, like, if I go to main.ts, this is those things. So we can actually just maybe take it from here, paste that, delete the update, delete the function keyword, and define player is, did we define as a ship, or yeah, ship. And then we are actually gonna have multiple asteroids, so let's do asteroids as an array of asteroid, and import those, define a constructor, and for now we can just say this dot player is equal to new ship 100 sure. What's that? Oh wait, no, let's actually go back to our main. I want to see what we had there. Okay, yeah, we can just reuse that. Go back to game. Okay, I'm gonna say this dot player equals new ship, and this dot asteroid is equal to new asteroid. Get rid of that. Actually I gotta do this dot asteroids is equal to a new array first, and then I will say this dot asteroids dot push. Okay, we can remove this later on. I mean, this will be controlled by some sort of wave system, right? We're gonna need that later on, but just to have some asteroid floating around on the screen, we can just have that. Just gonna leave here, import all the missing types. We need input, so I will do private input keyboard, import that, and go to update. I will say this dot player dot update, and I will say for const asteroid of this dot asteroids asteroid dot update. Same thing for draw, it will be draw. In here we'll pass in our context, get rid of that. Okay, move this all the way up. Private property input is declared, value is not read. Oh, it should be this dot input. Okay, all right, this looks okay to me. Go back to our main. So now we can get rid of most of the stuff here. So this is basically gonna become just like a bootloader or a bootstrap entry point for the game. So we will say now new game, pass in our input, and we're gonna say game.start, need that. So let's go to game and add that. I'll say start. So how do we start the game? We will need that ticker that we created before. So I will say private ticker, wait, import class. Okay, let's define it here. This dot ticker is equal to new ticker. And what's the frame rate we're gonna use? We're gonna get that from our main file and define it up here. fixed delta time, and now I will say this dot ticker dot on fixed update. I will say this dot update dot bind this. We do need to bind this because we're using a class. And same thing for on render, we will say this dot draw bind this. So our draw has context actually, and where is the context coming from? Okay, so in our game we will import the context. We will say I have it the same signature for now. In context we can import it from our view class. Or we can also add it as a dependency here. Okay, let's do that. Canvas rendering context, and we will do go up here, delete this, and go back down. Now I'll say this dot context, this dot context. Okay, I mean, do we need the draw to have delta time and now? Is that really required for render? When we did the flame, how did we calculate the time interval? Let's see, go back to player. Oh, we did that in update. Okay, so okay, what we can do, we can just get rid of all of this, and we can just have our context back. Canvas rendering context, and we will just bind our draw to the global context, or we can just do this dot context. Yeah, so if you do this right, the first parameter is already passed in for you. Okay, okay, we can try this. Go back to main, get our context. Okay, start the game. So in start we actually need to do this dot ticker dot start. We'll also have an end. I mean, we don't need end for now. The game can run all the time. When we get too hard and play pausing the game, we can have that then. What else? Let's see. So game class looks okay, main looks okay, player ship, yeah, looks okay. Yeah, one thing I also wanted to do is I think I remember last time when we defined our asteroid or movement, yeah, we have that type entity here, right? So let's define a common interface for all our entities. So that will be helpful for a bunch of different that'll be helpful for just having generic functions that work on entities rather than specific some specific entity like a player or an asteroid. So I'm going to create an entity.ts file, and I'm just going to export an interface entity, or we can say type is the same thing. We can say interface. It reads a little bit better. You don't need equal to then, and we can say, so we will have common things in here that are for all entities. We will have position, we will have velocity, we will have some sort of life. Okay, we can add life later. We are not going to use it anyways right now. So what else can entity have? We can define some name. It'll be easy to print things with that, and we can get rid of it later if we need to. Okay, let's import these. Wait, oh yeah, wait, we need an update function and a draw function. So this will take context, canvas rendering context, and yeah, I think this looks good. Go back and let's try if our game is working. Okay, it's not saying cannot read properties of undefined. Let's go to ticker.ts. This dot last time. Okay, so I think we forgot to bind our this. Go to ticker. Yeah, so we need to, in the constructor, we need to say this dot loop equal to this dot loop dot bind this. Go back. Okay, yeah, so I mean we forgot to clear the screen, so we will do that first. So we go to our game. In here we do clear screen, pass in context. Now everything should be back to normal. Okay, perfect. Is our input working? Yep. All right. Oh, actually the input looks to be opposite. So when I press right, it's going upwards, counterclockwise. Let me just correct that real quick. Go to player, arrow left, I wanna decrease the angle. Arrow right, I wanna increase the angle. Okay, perfect. What else? Okay, I think that's everything for the refactor. Now we can start working on bullets. Wait, actually we gotta use the entity here, so we can just say implement entity, import that. Name is missing, so I'll just say name equals player or ship. Okay, everything else should be the same because we already have all the signatures implemented. And we do the same thing for asteroid. Go to asteroid and we will say implements interface entity, and we will say name equals asteroid. Okay, it can be static actually, it doesn't need to be. Go to entity, name can be static. Okay, we can't have that on the interface. Okay, we can leave that for now, it's fine. We're not gonna change names anyways. Okay, so the interface is okay. Go back. All right, let's create some bullets now. So I'll create a new bullet entity in a bullet.ts file, and we can just copy maybe asteroid, paste that here. Now we'll change this to bullet, change this to bullet. So bullet is going to be a singular point, right? So we don't need a geometry or vertices. We just need some position, velocity. We don't need size either. We will just predefine the size of our bullet for a whole game. We don't need shape ID, we don't need this stuff. We do need apply basic movement, so we will import that. And actually, if you go back to apply basic movement, now you can get rid of this and then just import our entity. Okay, and everything should work as is. All right, and in here I will say this, and yeah, to draw a bullet we're just gonna do, let's go to our draw file, create a new function called export function. We can just say fill rect, pass in our context, position, and that's it, right? So we can actually just use this localization, and then we can say context dot fill rect at position dot x, position dot y. We need a size or width and height, so we can say width is number, height is number. In here pass in width and height, get rid of that, go back, color entities is fine, and we can just say draw or fill rect, pass in context, this dot position, one as width, one as height. Okay, yeah, looks good. Go back to our game class. Let's create a new variable here. We will say bullets, and then I will say bullet, and then I will define it to be a new empty array, bullets, and we will update our bullets in here as well. Say bullet of bullets, bullet dot update, and we'll also do bullet dot draw. Since we're looping multiple times here on independent like different variables, but they are all entities, we could reuse that our entity shared interface to call these functions, but then you need some sort of way to combine these two collections. I mean, this is okay for now. Later we could use some sort of generator or something to loop over all the entities at once. Okay, let's create a new bullet. So where should we add a bullet? Let's just create a random bullet on the screen first. We'll copy this code right here, and I will say this dot bullets dot push new bullet. Position will be something something. Get rid of that. Let's make it move horizontally. I'll say 0. Do we see anything? Okay, let's try to give it some more size. So I'm gonna go to bullet, bullet draw, fill rect. I'm gonna say 10. Let's see if we see anything. Nope. We did push the bullet in here. Give it a velocity on the x-axis. What if I make it 0? Should not be moving. Oh wait, is that the fill color that's the problem? Okay, wait, here, go to bullet again. Oh wait, okay, I'm setting stroke style. I need to set fill style. Okay, yeah, because we copied this code, that's why. Always double check whatever you copy. Okay, we have that block right there. Just gonna make the size small. Okay, we got the dot. Looks pretty small actually. If you see it, like it's right there. Maybe we can make it a little bigger. Should we use fill rect or then use a circle then? Yeah, we can just use a circle. Okay, go to fill rect, and I'm just gonna say create another function called fill circle position, and then I will take a radius number, and then I will say arc position x y radius 0 math.pi into 2. Okay, I'm not sure if I need to do begin path or end path. I think I do, so I'll do begin path, and then I'll do end path, close path. Okay, go back to bullet, and then in here I'll say fill circle, and then radius I'll give it maybe 2. Okay, that doesn't work. So in here we need to do let's do translate to position.x, position.y, and then do 0 0. Does that work? Oh wait, we gotta do context.fill. Forgot about that. It's not about this, so we will say pos.x, pos.y, Okay, yeah, it's right there. It's pretty big actually. Go back to game. Wait, bullet. Now radius is 2. If I make radius 1. Okay, that size looks okay. Alright, we got our bullet. We can make it move, and then we can call it for today. Let's see, go to game, give it some horizontal velocity. There we go, we got our bullets moving. Okay, I think that's the end of this video. Next time we're gonna do some really interesting stuff. We're gonna do some collision detection with the polygons and points, so stay tuned. I'll see you next time.